Okay. See, in the last class we were discussing about nonlinear equations of motion. What I was trying to tell is that if we were writing the equation of motion as, say, y equation of motion as etc. The see excuse me, the main issue was in this forces. So, what we said is that y is essentially y hull. If I were just taking this and n was like that. Now, y and n essentially we assume that no, this hull, the hull forces, let us say, or if I take both of them, v dot r dot v r delta. This is what we were saying. Okay. Now, let us take one by one, and what we did, say y hull. We said this is a function of v dot r dot v r, just when I take 2D equation. So, this was expanded as y v dot plus y r dot r dot. Okay. Now, in a linear equation we are writing up to this much, but what has happened is that in a non-linear, this was linear and this part is the added mass and this is the damping part. What I said in the last class is essentially that, see, this added mass part is fully known from equation and it is only the damping part that we keep expanding. So, essentially in a nonlinear equation what happened, I have added mass part that comes out to be, in fact, I can show you this will remain, but I end up getting an extra part that is actually given as what you call x u dot u r. See, this part comes out, this additional part, you know, this expression I showed it in last class that the entire expression for inertia force is fully known. So, it becomes like that. See, the problem, this is the inertia part or added mass part. Problem was with respect to this part, which depends on v and r. Okay. So, here what is happening is that it turns out that this force can be, okay, or some people will replace this, I will write okay, then let me write it down, then I will tell you what. Oh, sorry. Okay, see what is happening now. This is a very important point. See, this part of the force is fully known to us, that is the added mass part, and it assumes only a linear part, and there is an additional part that comes in like this. and in fact, this can be neglected because x u dot is very small. You know, x u dot, this term is extremely small, so it can be neglected, this part. But the most important point is to recognize is that when I meant by nonlinear is that y against v, it is not a straight line. Basically, it turns out that because it may not be a straight line, I need to have an additional part either this way or this way, depending on how I model. Now, there are two models. Normally, people will take, if I take only this, see, after all, what I meant is here again, I will like to show you. There is a lot of repetition, but let me also show this. So, if this value goes like that, you know, what is happening is that if I were to use only yv, what it means? It means I am presuming that this y is varying like a straight line, right. But actually, I find out that y may not be varying as a straight line, it may be varying in a curve. So, what do I do? I have to model this curve because I need to find out y as a function of curve. So, you know, this graph can be fitted. If I call this, for example, y versus x in a graph, then y can be fitted as a1 because it goes to 0 0 plus a2 x square. That is good enough to give you this curve, some curvature. Or of course, now of course we can also use yx plus a2 x cube. So, here that is what I mentioned here. Why it is used this? See, basically you need a nonlinear term, an addition higher order term, one term to make this straight line curved. Now, which one we should take? A cubic? Obviously, a second order polynomial is good enough, the way we do in any you know, like ship hull you know, like description. But if I use a2 x square, the problem that remains is that I want to make sure that the y value and x value are of same direction. That means, this is y force and this v, if I were to write this way, if v becomes negative, then y must become negative. That means, this graph must basically go like that, and that is not possible by this, because this particular part would make sure that, you know, when x is negative also, so this value is positive, right. So, this graph will actually show something like this, going up like that. So, you have to then take this as a2 x x, which is what is called, it will be actually, now the symmetry relation will be mentioned like a cos curve. No, not a cos curve, like a sine curve, sorry. You know, the sine will go like that, it will be like a sine curve, that is, you know, that negative side, sine minus theta should be minus sine theta, etc. Or of course, you can take to, some people may have it trouble with this mod. So, you may take x cube, but the main point is, of course, is that what the most important point of nonlinearity means that either you take or this means actually what you are trying to find out is capture the value of y against v, which is like this. That is the main thing. Main thing is that I did not assume it is a straight line, because now I want to see the behavior of the body not just for small value of v. If this value of v was very small, value of v was just within this range, then of course, I could have presumed v to be straight, y to be straight line against v. But now my interest is to go beyond that, and when I am doing an experiment, I want to find out exactly how y versus v. That is why the question of model comes in. So, I have this. Now, this is a question of modeling, either you take this or you take this plus this, or you can even take 3, it is up to you. Normally, taking 3 may not mean much, but some people can also take 3. So, therefore, the question of how in reality what is nonlinear coefficient, there is no fixed thing, it depends on how much you want to take. See, first you have to model with certain coefficient. Basically, I have a curve, I have to therefore fit a curve with some assumed polynomial, that is my model, and then my next job would be that what are the coefficient for the polynomial, like what is my a1 a2 or a1 if I call it a3 or a1 a2 a3, depending on which one I choose. So, first I have to assume a model, then I have to find out the coefficient for the model. Remember, these are coupled, there is nothing like nonlinear derivatives. It depends on which nonlinear coefficient you have used to model the force, and that one are the one you have to determine. Now, you see here, this is I just show you a possible model, this is like that, this is like that, and when I take V and R, for example, when I take combination of V R, I can have either V R one term. Of course, here actually a mod part comes in, that one has to take one of the thing to be taken mod. Again, in order to avoid that, you can take this way VVR plus VRR. This is called a cubic. See here, linear and cubic term, or linear and quadratic term, or some people may take linear, cubic, quadratic term. So, basically these things are showing V and R coupled. Now, this is of course VR, but now okay. So, you understand that part, right. So, this part is what we are talking of non-linearity. So, ultimately what happened, supposing I took this coefficient, what happened, say this model for Hull forces, what it turned out that I have to find out by experiment unknowns. What are the unknowns? This is one unknown coefficient, this is one coefficient. Okay. Now, I come to this later on, because what happened, this u r can be coupled with this r apart, and I will show this little later on in experimentally. Basically what happened, whatever is varying with r, see this y r plus x dot u, this becomes one term, because here I end up getting, see this and this combined becomes y r plus x u dot u into r, and I can call this to be nu y r r. I can absorb this within this basically. Anyhow, but as far as coefficient is concerned, the other coefficient is this one, then either this one or this one, and this or this or this and this. These are the terms I have to find out at in the y coefficient. Now, I like to write this end part little bit, because end part is an important part that comes in, especially with respect to one part of the moment, this end part. Now, if I write n, the again I have got n v dot plus n r dot, but there is a very important term that comes out. This is okay. Or I should write here and as usual now there is a point of my writing this. So, I am just writing this still. Etc. See here, one most important thing that is that bears like repetition or emphasis is like this. See, if you look at this, these are exactly same, but the only difference that comes in this case is one term, basically this one, added mass term. This value here, this additional part came this value x u dot u. Now, x u dot is surge added mass in the forward direction, ship is here, added mass in this direction, very small, you can even neglect it. Okay. But this one y v dot minus x v dot is very small, but y v dot is added mass in this direction, because y v very large value. So, this value becomes a very large value, this y v dot u v, one thing, and y v dot is always negative, always a large negative value, because y v dot is minus of surge sway added mass. So, this is a negative value. Now, you see this term is combines with this term, because these and these are v depending on v. Suppose I have got a certain v, say I have got some plus v, then I am going to get a negative large force here, and depending on value of n v positive or negative, I will get a force here. Now, remember we have mentioned earlier, if you recall, if n v was a positive force, was positive number, it was always trying to stabilize, because we were saying in order to make ship more stable, n v should be make more and more positive, less and less negative. Suppose n v was large negative, try to make it less negative, means when n v moves towards positive side, means turn is important, it is trying to make the ship stable. That basically means if I add a for example, a skeg, for example, a feather at the end, then NV becomes towards positive. So, NV make that means this combined term that against V, what it means is that, see, suppose I get a positive V, then I should try to get a positive N moment. So, I let me explain this here. So, if I get say this V here. So, if I get a positive V, if I go this side, this is my basically positive N. If I get more moment this side, okay, it will try to stabilize the why? Because remember that we have always said that the center point here, this point P is given by this distance NV by YV, and as it is moving backwards, it becomes more and more stabilizing. Now, NV is always negative. So, this was taken as negative. So, it becomes more and more positive, it becomes stabilizing. Essentially what it means is that obviously, if N was supposed to be positive with V positive or less negative, that means it is trying to turn this side, I can end up getting a positive moment stabilizing. But here the problem is coming here, this value, this particular term is always negative for a positive V, because YV is very large, YV dot is very large number. So, this value always represent a destabilizing moment, and this is known as a monk moment. In fact, this is something that is very important in our marine object. And I can tell you one interesting thing, that whenever people try to like take the dynamics of aircraft structure and missiles, for example, and try to use that for marine bodies, they never understand that added mass forces are important, because in aircraft added mass forces are very small, because the acceleration of fluid forces are extremely small. So, there you can neglect it, but in marine structure this becomes extremely important, and because you can see that YV dot is like almost like a mass. YV dot is proportional to the mass of the vessel. The 20,000 ton there, it will be around 20,000 ton into UV. You can imagine the nature of the force. This is a force that is trying to destabilize it, trying to make it go away. So, this force is extremely important to be understood, and of course, in our equation of motion, we can combine these two, once again these two part, and write it at NVV, because why I am saying is that this is therefore a coefficient multiplied by velocity gives me the net force. Here also is something into V, something into V. So, that means the total thing into V, and I can call that to be the equivalent NV coefficient. Basically, this NV comes out from the real fluid effect, this is coming from the non-viscous or ideal fluid effect, acceleration effect, and these two combined is basically, as far as nature is concerned, you are not able to find out this and that separately. Okay. So, what is happening? You end up getting expression like this. This is nonlinear. Now, again, before I go to this experiment, I have to tell you that, see here, what did you find out? Once again, I find out I need to determine added mass coefficient, which is of course only linear one, because there is no, and this, as I mentioned last class, exact expression is no. So, there is no nonlinearity there as far as this is excepting this part. Here I need to find out this and this or this and this or this. It can be also and. Some people have modeled this and this, all of the three. As I told you, essentially this is by trying to tell you how you model this graph. This graph can also be like that, whichever way. So, it is a question of how you model this stuff. So, this also it can be anything. So, that means I have this linear coefficient, these are known as nonlinear coefficients. See, VV or VVV, VR or this thing. This is known as coupled coefficient, also nonlinear, VR or VVR and VRR. So, I end up getting these coefficients. Okay. So, this is one part. Now, this is only with respect to the hull forces, but there is also coupling with respect to the rudder forces. Let me talk about the rudder for a minute. Before I go, see here the rudder force, let me talk about this. Before I go to the cap tip test. So, let me look at y rudder. This is a function of delta, rudder angle. So, this you can write it as y delta delta, there is only linear term, but plus, now this linear term only, but sometime you can also write basically y delta 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 cube. This is the common model instead of taking delta bar delta, because of the symmetry once again, that if you give minus delta you should give the same value. Same thing, you can actually take here y delta 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 also. Normally people do not take it, as I told you, essentially what again you are trying to look at is y versus delta, the variation. Now, but the same thing with end rudder. Okay. Remember, these two are normally taken together. There is a reason for that. You see here, if I take here a rudder here, so this gives a force here. This force becomes y rudder here, and if I multiply with this distance x, then n rudder equal to y into x approximately so, and when depending on the point of center to this point, and this is approximately L by 2, because this will be around L, half the L, and this will be very short distance. So, this distance x is so what I am therefore telling that if I take this 2, I must take this 2, do not take this 2 and only this one, because essentially y and n are somewhat connected. See, if I were to take a modeling of y force with this 2 a nonlinear variation, then n also must be so. That means, if my y versus delta is taken to be like that, you should not take n versus delta to be straight line, you also should take similar variation. That makes sense, because n is nothing but y into x. Okay. This is only the linear nonlinear part. In fact, mostly we do not even take this, because you will know that you operate this, I mentioned last class, to an angle where it may be straight line. This is a hydrofoil section like an aircraft wing, but symmetric. So, there is a CL there, lift coefficient, which is similar to y. But now I want to tell one more thing, y versus delta we did that, right, but there are more complication may come. Now, y rudder can also not only it can also depend on this. So, in that case I can have not only y delta delta plus y delta q delta 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 cube, I can also have y v delta v delta, or of course, y can have, normally what happen is that you do this or you take this way. You can have also y r delta and equivalently term. You can also have y v r delta v r delta. So, now my point therefore is, see, each two, what is the meaning of that? See, that imagine this, what is the physical meaning of that? I want to tell you this. See, here what I am saying, there is a ship here and I give this y force certain delta angle and it is giving me certain force. But now supposing the ship is actually turning with a v, with a velocity here, and of course, that means, okay, at this point I gave it here. So, this delta I gave. So, this force that you end up getting here, this y force normal to this body, may not be same as this y, because in this case the body was going on a straight line, but in this case it is having a small v. So, that this is what will happen, that therefore, I will have, see here the force y rudder may be, if I take y delta delta, but here y rudder may be y delta delta plus y v delta v delta. Here of course, the v is small 0. What I am trying to say is like that, see, the force here and force there may be different, Why? Because here I am going on a straight line, so flow comes in certain direction, I have got a y force. But here same angle, delta angle I am given, say 20-degree rudder, but the ship is already on a turn and it has got certain v and also certain r. So, therefore, y r delta also with this force is different. Now, there can be a force arising, a correction on this because of the fact that the y force now applies on a hull which is already having some v. So, therefore, y is a function of v and delta. So, therefore, rate of change of y against v and delta, del square y by del v del delta into v delta. So, this term comes in. So, this is the physical meaning of that question of modeling. As I said, these are normally small. So, it is a question of a modeler. Should I take this? Up to you, if you want to take a nonlinear model, or should I take this? You have to decide. A modeler has to decide, and of course, certain experience has come in which people are nowadays, there are certain standard model being taken, where normally cubic is taken and these terms are taken up to 1, or sometime actually what is happening, there is a competition, either you take this or this normally. It turns out there are dominant feelings. One is a European HSVA model, one is a so called American model. Some people take only this and this, some people take instead of this and this. But most people will take a coupled term. Now, I can say that these are the non-coupled term because it is just telling me y varying with delta. These are what is called coupled derivatives, v delta etc., etc. These are called coupled derivatives. This is a question of modeling. Now, if I understood up to this point, then we can now kind of list down what are the kind of derivatives that we might end up having to find out. What are the derivatives that goes in a typical nonlinear equation of motion. Okay. So, this is what we have said here, only y, the same thing will apply to L. So, let me now show that suppose I want to list the derivative, y derivative say, and then also I am only looking at y and n. So, y derivative say, or coefficient you can call derivatives So, we have y v dot, y r dot. Okay, then I may have y v v or y v v v v cube. Then I may have y r r or y r r cube. I may have y v r or y v v r and y v r r. I can have y, see here, delta y delta delta delta. I can have y v delta, or I am just writing those ones, r delta and say y v r delta. One couple term I took, you can also have more. So, you see now why I mention this, see, because when I do experiment, I would at the same shot be able to find out all, because in an experiment, you remember, I am going to be basically measuring y versus some parameter, say v r whatever. Since I am going to measure that, question of fitting and then getting all, there is nothing like I will just find only one. That is why I wanted to mention that, because when you do experiment, you of course will find out all. Nature will not try to tell you how you model it. Nature will give you exactly how the force varies for a given input parameter. What is my output for an input? That's what that means my y for a v. That's what my measurement will tell me. We will of course talk how we can isolate and measure, that is different. But see, you end up getting, therefore, if I were to note down the nonlinear derivatives, then this part, this side is nonlinear derivatives or coefficient. This is linear, these are nonlinear coefficient. Okay. Same thing will happen to n. In fact, one can keep progressively more complicated, because I only take y as a function of v and delta, but if you take also roll motion, then two more parameter come phi and p, roll angle as well as roll motion. So, there will be much more derivatives that will come, that depends on the. See now, now I come to this next part, the captive model test. Obviously, one of the biggest job therefore is that, well, I know the derivatives. Of course, I know only this linear ones, that is I basically I know this and the corresponding n as far as my directional stability with control fix is concerned. So, this is very important, this is very important, this is very important. Normally, you will find out that these values can be estimated fairly well from theory also, but these values are much more important, and we have seen that also. This and the corresponding NV, NR, these are the one that decides the stick free stability. Stick free means control fixed stability, stick fixed stability. Also, we have seen that for turning circle, this and the corresponding n values are the one that tells me the turning circle radius to the first approximation. You know, the turning circle radius, drift angle estimates. You want to make an estimate. Normally, you will find out that if I use only linear derivatives, what I get if I take nonlinear derivatives will be tighter turn. That means, if linear gives me this kind of turn, nonlinear derivative will give me tighter turn normally. So, which means that I had an IMO requirement that my ship must turn within 5 ship length and all the stuff. So, if I could estimate them based on the linear derivatives, I will be more or less sure that the ship would meet the requirement, because nonlinear derivatives always tend to make it smaller, tighter turn, faster turn. That also makes sense, because nonlinear forces go like that, because that means in a linear you are predicting my y force was this much, but actually the force is much larger. So, naturally that normally so. So, we said this. Now comes the question of finding this coefficient experimentally. That is what we were talking, experimentally. Remember, I need to find this coefficient experimentally. This and the n, and as I said, if there are other, what are the tests we and how we can go about it, that is one important part. Now, once again, if you see that, see here again, if I write that y was a function of, what is this, v dot r dot v r delta. I am just taking this. So, when if I want to find y against v, what I should do? I must make sure that I have only v to the model and nothing else, because if I had other thing else, what I would measure would be y arising from all the factor. Let me again, this is a very important concept that I need to experimental. Let me write it down. Or I say sometimes I use the word coefficient. See, everybody agrees, then there is no denial that you need to determine the hydrodynamic derivatives, because they are the one that characterizes the maneuvering behavior of the hull. That there is no doubt, right? We have seen earlier also. So, the next question of course is that how do you determine that? Experimentally, you cannot go build a ship and then measure it. You might do that, but that would have been after the design. The word captive model test, you know, that resistance test that you do, etc., means that you are restraining the model in some motion. It is not free running model that you are just making it. You really cannot do it because you have no control. Resistance test, what you do, you hold it, allow only to heave and pitch maybe, and then tow it. Captive model test. These are captive model test. Now, here comes the question. See, let us say y and n, let us write this way. They are function of various parameter. I am just writing up to this much. Now, let us say I want to find out, say y say v dot. What does it mean? I must measure y force arising. What is this? Y force arising because of v dot. So, this say minus y if I do, I had to measure these values. Then I draw a graph, then take a slope, right. I need to measure this. I need to measure in experimentally what is my y force coming because of v dot, or what is my this coming because of that parameter, whichever parameter. What about the other parameters? They should be 0, not straight line, they should be 0. So, this is the fundamental requirement, that I have to ensure that when I want to measure y against one parameter, others are all 0. Otherwise, what would happen? The force I measured would have come because of also that parameter at the see, for example, there is both v dot and v are there, then what the measure I value would be v dot plus y v, maybe plus y v. So, you see how do I isolate them? The what I measured will be coming for all of 3, or if there is r there also, all the complication will come. So, what I have to do, this is an important point, you must understand that if I want to measure y or n against one of the a derivative against one of them, that which means I am looking at variation of that against that motion only. If it is y versus v, only about v, I can of course measure this to both, because I will have a graph like that. But I have to make sure that other parameters, see if I want y versus v, then v dot r dot are 0, delta is also 0. Okay, delta 0 is not a problem as far as experiment is concerned, but how do I do that? So, this is where the challenge or designing the test comes. You see, as you go progressively higher, resistance is the simplest test, just tow it, then skipping, then maneuvering test, you keep going to more complexity. So, I tell you the first test, which is the simplest and first test that can be done in a towing tank. Actually, I should say I should not test this thing. First test is we call straight line test. This can be performed in a towing tank. I mean, what I meant is that the first test, that the simplest test is what is known as a straight line test, that first we will discuss, which can be performed in a normal towing tank, and the test goes like that. I have this tank here, I have this center line of the tank here. All I do is keep the model, incline, tow it there at u equal to u1 you can call, and measure with a dynamometer here whatever y and whatever. You see here what we are doing with an angle of attack, say. Now, here this angle of attack is taken from here, see in a resistance test what you do, you have a model that is towed and measure x force, that is what you are doing, right. In a what do you do in a resistance test in a towing tank? You have a model, okay, you tow it along a straight line. What do you do? Measure x force with a dynamometer. Here what we are going to do is that this first test you do the same thing, but you now tow it on an angle of attack beta, and you measure with a dynamometer y and n. You can also measure, x, you can also measure x, like this x, but more importantly y and n for maneuvering. This way you have to orient that is a question of instrumentation. You orient that dynamometer this way and measure along y, remember, is actually normal, y is actually transverse axis to the ship, that is this is longitudinal axis, x axis, this is y axis, the ship, the transverse axis to the body fixed y axis. So, you measure y and n. What did you achieve by doing that? Remember, what is beta? Now, here comes the important question. See, V dash is V by V, which is equal to V by U, because if this small angle is there, this is equal to actually minus beta. That we have said before. See, obviously, what is happening is that if you draw this thing here, then because beta, the way you are defining is that you are measuring from vector to the x axis. So, this is becomes, see, this is minus beta for plus V. Remember, in this diagram, V is this side, which is plus, and you are measuring beta from the velocity, that this is actually V here, which is close to U. Actually, this is U here. What is happening if there is a small beta here? You can easily find out that U is equal to V cos beta and V is equal to V sin beta. If beta equal to small, then U becomes equal to V and V becomes equal to beta, minus beta, with there is a minus sign here. Okay. Therefore, V dash, which is actually V by this V, which is V by U, is equal to minus beta. That is a non-dimensional value. Understood that? See, U is V cos beta, V being the velocity vector, right? Remember that, again I will tell you this way, V is equal to U square plus V square root over is equal to U, because V is small. When beta is small, V is small, these two first order, it is like this. It's just like saying sin theta is theta, cos theta is theta, you know, cos theta is 1. If beta is small, you can also see U is V cos beta. If beta is small, it will be V, and small v is capital V into sin beta, sin minus beta, that is minus beta for small. So, if you do not like, you can also put large number, does not matter, but it just was showing. Suppose you do not like this approximation, but you will know exactly what is a V. The point is, of course, that you are here able to, you see, what else is there in this? What is R? 0, because I am not rotating it, right. When I am translating it this way, what is my R? 0. What is my R dot? 0. What is my V dot? 0, because I do not have any acceleration. So, what I achieved? I have only given V and could measure y and n because of that V. You understand that? No, in this case, I could only impose a velocity, transverse velocity V. U of course will be always there, forward speed, because U is ubiquitously present, there is a mean forward speed always. So, here what I did, my speed V, V dot, R, R dot, this is 0, this is 0, this is 0. I could only have this, which of course is minus beta. So, not only that, depending on what beta I tow, I could change different V. So, what I do, if I were to tow it at beta equal to 1 degree, 2 degree, 3 degree, 4 degree, which means I am having different value of V dash. So, essentially I am doing this test here when I could measure for beta, different beta, y force and n moment. In other words, what I am achieving in this test very interestingly is that I have minus beta, which is equal to V dash, and y, I put it minus y here, because you know typically this, otherwise this way the graph does not come, minus n maybe, or n maybe, does not matter which way the n is. Why I put minus y? Because what is happening, then I do a test, beta equal to 1 degree, I get a value here for y value, forget this now, okay. Why I put minus? Of course, because you know typically for plus beta dash you will get negative value, that is why I put minus. Why minus? Actually it is nothing, I can put plus y and then the point will come here, because normally what would happen, obviously if I give this kind of angle here, okay, then I will measure the force coming this side, and I am calling by axis, this is plus. See, when you do a measurement, you will get the instrument you know recording say 20 Newton, but obviously in this our subject the coordinate system is very important. So, you have to make sure which side the force is. If the force is this side, I am calling negative, because my axis system is positive. So, I got, let us say the instrument showed me force this side 20 Newton, that means my measurement of y is minus 20 Newton, right. I mean this is very simple, and what is the beta? I have given this side angle, which is minus 1 degree, which is plus V dash. So, I have done that. So, that is why I just want to show here, it does not matter if you make it plus, the point would have come here, that is all. Okay. So, then I do another one, go here, I do another one, go here. So, obviously, I do a few of them. In fact, I can go, in fact, I need not even write this, I can write actual V dash as measured with respect to sine of minus beta, if I want large angle, you know. I can also write this way, V dash as minus sine beta. I mean, you know, because we are doing large angle. So, what would happen? You end up getting these points here. Of course, you have to repeat that exactly on the other side. You know, you turn it this side with a minus value, because you have to always do symmetric, then you end up getting this value. So, you end up getting a graph. Well, obviously, you have not got this point, remember, you end up getting a graph like that. Okay. Now, you tell me from this what all coefficient we can find out. Obviously, I can find out yv. See, now what is happening, yvv plus, depending on what model you do, this or yvv plus yvvv cube, or I can even do a combined model, what is called combined. See, if I now the question is like that, I have this value, or let me put also linear value only. So, this is pure linear. Suppose my model was pure linear and I say that I have only linear model, I want to use this in conjunction with linear equation of motion. What I will do? I will fit a least square fit curve, let me call this y, let me call this x, y equal to a0 x or a1 x. You can also have a0 actually if there is an offset there. Some models will have an offset, that is there is an residual value at v equal to 0. It may happen because of there is a design problem, it was not symmetric, you know, like exactly port starboard is not symmetric, as you go there is a slight force, possible, it can happen. I am just not going to those details right now. So, if you do that, you fit this graph, a1 is this, simple, this equation. Now, I want to say I want to model this, and my model is this, and I want to find out what you do. You model for this y equal to a1 fit plus a2 x square or whatever, you know, like xx. So, you have now fitted a graph like that, find out the coefficient, and this is my yv is this and yv is this. Okay. If I want to now fit this one, I can find what I am trying to say, that you have actually got y versus v. Now, depending on, so it is not straight line, suppose it is a straight line also, then depend the model you choose, you take that curve and fit that curve, least square curve, simple as that. That is why I wanted to have this nonlinear thing, because remember they are coupled. When you do the experiment, there is nothing like linear and nonlinear. Experiment is not bothered what model you took, experiment simply gave you what is y force against v. It is up to you to model, and you would have modeled with y. Normally y by v actually shows not this, in fact it mostly shows like this. In real life it shows actually like this, it becomes larger at larger, this thing, you know, like typically I am just saying for typical this thing it may look like that. So, obviously in here you use that. Now, you see that the interesting points are many. Suppose I use this, say this now if I what is my, okay, let me I just want to go for this little bit here. So, my let us say graph was like that. Now, if I use values like that, say in that, remember what is my yv? Yv is actually slope, this slope. So, if I took only the linear coefficient in a measured fit and use this for finding out my stability, I may find out the ship is unstable with C negative, but actually the ship may be stable, because actually you are trying to tell the force is more, actually the force is more. So, you see these things are very important for you to understand, that linear derivatives gives you only a behavior at this point, but unstable ship, directionally unstable ship with coefficient like with the control not working does not mean it is going to be unstable. It is exactly the same as angle of lol, somewhat similar, analogous to that. A ship is negative GM, does not stay at 0, unstable, but it will go to 2 degree and stay, becomes stable at 2 degree. So, you must remember this is where the question of nonlinearity comes in, because actual y versus v dash is like this. Now, okay, we have just said that. Now, I just want to end this test at this point. I want to tell you. So, if I do a straight line test, tell me what derivatives in this list I can find out. Where is that list? I bring that list and I try to tell you. So, I have straight line test done, which is very easily doable in a towing tank. I do not need a facility for that, but I do need an instrument, a dynamometer that can measure y and r. So, if I want to do it today in our towing tank, I may not be able to do in our towing tank, because I do not have a dynamometer that measures y and n. You see, I have a dynamometer that measures x only, but I need a so called 3 component dynamometer, means x, y and n it should be able to measure. If I have that, I can do this test, but having done the test, among this coefficient what all I can find out? Only this line, or rather I will tell you, I am able to find out among the y's only this line and of course n, equivalent n, nv, nvv, nvv cube, right, y of this and also corresponding n. But now I want to ask you this question, you tell me this, anything else you see here that can be found from this test? Remember the test setup, you know, this is the setup of the test. Anything else we can do from here? Right, I can do this. How I do this? Not only that, I will see I can also do this. How I do this? I will now tow the model with V0, but with a delta. Then I will measure y versus delta. I can do that. Remember, my V is 0, okay. I can do y versus delta. Then I can measure this. Then again I fit the graph. It is y delta delta plus y delta 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 q, depending on what graph. Basically, it may not be this way, it may be like that more. You have to do it both sides. So, I am able to y or n versus v and delta. These two can be varied, keeping the other constant. Okay. That means, I can among these I can only get linear sway derivatives, because y versus v are, v is sway motion, y v not linear, linear and non-linear. Let me call the other one sway velocity derivatives. This is sway velocity, if you call v, v dot, r, r dot and delta, sway velocity derivative I can find out, linear and non-linear. That linearity does not come in picture here. I can find out rudder derivatives. Now, after this break, I will tell you how I can also find out y v delta, okay, y v delta, or if you want y v v delta, y v delta delta, the cross coupled terms. It is possible because I have varied these two, so I can always vary these two independently. I will tell that later on. So, essentially of so many coefficients, I can only find out few by this test. This is test number 1. So, anyhow, I will this class will formally be over now. Then next class I will tell you how v delta can be found out, and then we go to the next level of test type 2, where the rotational derivatives are found out. Okay, so with that I will end.